Hi everyone, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Great, thank you for confirming everyone. So for those who have joined for the first time, my name is Neeraj Kedia and let's get started directly on a discussion on Python programming. So here we are going to discuss on what exactly Python is and the features of Python, who uses Python, so starting off with Python basics, including data types, operators, flow controls, functions, and fine handling as well. So if you talk about what exactly Python is, so Python is the easiest language to start with for those who are coming from non-IT backgrounds. So it was created back in 1989 by Van Rossum, and then it was again basically inspired by one of his favorite shows as Monty Python. And it's a general purpose, high-level integrated language with easy syntax and the least amount of grammar. So Python has, again, there are multiple advantages of using Python. Python is ranked as third most popular language, followed by JavaScript and Java. And in terms of the features, there are multiple features of Python. That means it is, first of all, simpler. Now, in terms of simplicity, we can have to think less of the syntax of the language and more of the code. It is open source. That means there is no licensing required here. It's free for everyone to use and alter as needed. It is portable. That means Python code can be shared and it would work the same way it was intended to, seamless and hassle-free. It is easily embedded and extensible as well. People can have snippets of other languages inside it to perform certain functions as well. We can bring in functions that we may have defined in C, C++, even Java as well within Python. And then it is integrated. That means the worries of large memory tasks and other heavy CPU, we can say tasks, they are all are taken care of by Python itself, leaving us less to worry about coding. And then it has a good amount of libraries. That means it has multiple libraries for every possible function that we can think of, so that we don't have to create those functions from scratch. And then in terms of oops, okay, it is object oriented. That means it simply helps us in breaking down complex real life problems into such that they can be coded and solved to obtain the solutions as well. To sum up, Python has a simple syntax. It is readable. It has great community support for anyone to get started. So if we talk about Python basics, then first of all, we need to install Python. So in case we want to work with our own Python CLI, then we can navigate to python.org from where we can get Python access. Let me share that with you all. So here we can either use Python.org to get the access to Python CLI and Python ID to get started. We can use this tool, or we can make use of the IDs like we have PyCharm. So PyCharm is one of the popular IDs that we can make use of. We can also make use of Jupyter Notebook as well in case we have it configured. Or we can also make use of Colab, which is offered by Google to start working on the machine learning strategies. Not just machine learning, but again for working on Python. And here we can download any of these IDs. Even PyCharm is offered as a part of Community Edition. So we can choose the Community Edition to download it for free. So there is no licensing involved here for Community Edition as well. Let me share both the links with you all. So you can choose any platform, whichever you are comfortable with, to get started working on Python. So once we have installed Python, so now in terms of writing a first program in Python, we can be specific. That means, yeah, first of all, let's understand different available data types available in Python. So in Python, we have numeric data types, we have tuples, we have sets, we have strings, we have lists, we have dictionary. So there are multiple data types, just like we have in every other programming language. So first of all, if we talk about numerics, so we can define numeric data types that are used for storing the numerical values, and they are not mutable. Mutable means something that can be changed, right? And not mutable, or we refer as immutable, that means that cannot be changed. So here we have integer, float, complex. For example, if you want to get started, we can simply define. Now in Python, we have to define values. For example, if we want, we can define value, suppose as x is equal to suppose 20, and then we can define, okay, y is equals to suppose 10, And then suppose here we want to define Z is, suppose Z here is equals to suppose X plus Y as a part of operation that we can perform. And then if you want to print the statement, we can simply define print. If you want to print Z, we can type in Z, and then we would be able to see the entire command being printed. Now here, as we can notice, we don't have to worry about declaring the data type. Like in Java, if we have been working with Java, so in Java, we had to define integer X, right? We had to define float X, we had to define double X. So again, this was the strategy. This is the strategy that we use in Java-based programming languages. But here Python is a dynamic one. That's why it automatically understands what is the type of data that we have declared here. For example, even if we want to declare a string here, for example, here we have data, we can type in suppose as welcome to Python. So again, it automatically understands based on the input what kind of language, what kind of data pointer it is, whether it is a string, it's an array. For example, here we want to add array, so we can add array as well. For example, here we want to define as array. Now, in terms of array, if you want to declare this as an array here, so we can simply start declaring thing as an array. So it automatically understands the data type being used here. We don't have to declare it specifically. And now suppose here we want to print Z. We want to print, suppose, the data pointer. We want to print the array. So here we don't have to specify a long statement as system.out.println. It's a simple plain English print. We don't have to get complicated. And currently we are using PyCharm, and again we can simply type in, and once we are done with the code, we can simply run the code here, and this is going to execute, and there is no compiler required here as well. Like we have to, first of all, in Java, we have to first of all compile the code, although we have a bit of compilation is done here, but again, not at the complex level as other programming languages. So as you can see here we have printed Z. So Z as what we define X plus Y. So here we define Z as a part of the arithmetic operations like X plus Y. So it automatically added that. We can do multiple arithmetic calculations as well. We can find, next is we had defined the statement to print data. So on the data we have the string value as welcome to Python, and then we had defined array where we define array elements, right? And that has also been printed. So that's why these are different data types available. Same way we have now here we also have list. So list has is the same as array, but again list can have heterogeneous data. For example, currently we have declared an array here, right? So again, an array has to be defined here having the same data pointers. Either all the elements should be a string, either all the elements should be a number. But again, if you want to have this kind of heterogeneous list, then we can do that by using a list, right? So for example, let's say here we want to add as Python Java. So now, again, this is going to be declared as a list. And remember, whenever we are adding any kind of the string values, and that has to be placed inside a double quote. That has to be placed inside a double quote. Then only they are going to be treated like a string or a character value. Because numbers, they don't need to have any kind of double quotes, but again, string values and characters, they simply need to have a single value, whereas for string, we have to define a double quote. And that's why we can see it has now been interpreted like a list, where we have heterogeneous type of data sets. Then we have tuples. So tuples are same as the list, with the exception that they are not mutable. That means, again, we cannot modify them. So for example, let's say if we define the array, right? And again, we redeclare array here, as suppose we declare the array as, now suppose as 4, 5, 6, 7, 8. So again, we can also make it heterogeneous. For example, let's say change. It can be any value that we want to define here. So now if we rerun the same thing here, as you can see, it has been redeclared and it has been reassigned as well, correct? But again, if we declare this as a part of the tuple, suppose here we change the bracket. For tuple, we have a normal bracket. And now if we try to execute this, then it is not going to be declared here. Because again, at the end, it is going to be mutable. That means, again, whenever we are going to declare that, then if we rechange the same value again, then that is something not allowed. Suppose if we go ahead and change the same value, we make the first list as list itself, right? So again, it has to be not mutable as a part of tuples. Then we have dictionary. So dictionary is basically having a key and value structure. For example, dictionaries are mutable. That means again they can be changed. So when we want to store something as a key value structure, for example, let's say we go back and here, now just to avoid confusion for everyone, so we can define suppose as a list, and again under list we want to define the list of students. For example, here we have suppose a name, and then for name we want to have a key and value pair, right? So again, a dictionary contains a key and a value pair as well, right? So here we can declare a value. For example, here we can define, let's define this as characters instead of strings. So suppose here we have name, and then we can add the value of name, suppose as John, and then we can add a comma. Again, we can define, suppose here we can have as subject. So again, on a subject is what is a key. So subject here is a key, and then we define the value, suppose as mathematics. Mathematics is what is the value. So now what we're doing here, we simply define this as a part of dictionary. We can name it as dictionary itself. And now if we want to print out this dictionary, we can simply define print, and then we can define dictionary itself. So now again, we run this up. Again, this is going to be declared as a key value pair. This name here is a key, and the value assigned to this key is John. And this is again the subject is a key, and then we have value assigned as mathematics, so that we can refer to these things through these different values as and when required. So tuples are something that cannot be modified as compared to arrays or lists. All right. And then we have sets. So sets are basically the unordered collection of unique elements, and they are mutable. So for example, let's say here we have defined a set. We can always modify the set to whatever we want. And then we have strings. A string is what we had discussed. So we can define strings in double quotes, and we can save the value, which can contain characters and numbers as well. Next, we have different operators available in Python. So if we talk about operators, then operators are constructs that we can use to manipulate data, and they can be used to describe actions that needs to be done. And they derive information from data, or we can say we simply manipulate them to obtain different solutions. Like we have used the operator already. We have used the operators such as the operators available for addition, for subtraction, for multiplication, for division. We can do multiple things as and when required as a part of working with different operators. So we have the arithmetic operators, we have assignment operators. In arithmetic, we can perform multiple calculations. For example, we had discussed if we define suppose as x is equal to suppose 5 and y is equal to 7. And now if we want to perform calculations in the print statement itself, like x plus y, and then this is going to perform the addition, and then in terms of the result we are going to see 12. Here we can go ahead and plus, we can simply perform the subtraction as well, we can perform the multiplication as well. Multiplication is referred by asterisk, it is not referred by x, it is referred by asterisk. We can also perform the division as well. So whatever we want, that can be easily performed as a part of arithmetic operators, whatever we want. And then we have the assignment operators. So using assignment operators, we can assign the values where we have equals to, plus equals to, minus equals to, multiply equals to, divide equals to, and again here we have the modulus as in terms of finding the remainder, and the exponential ensign. For example, let's say here we want to define z. We want to define z is equal to suppose y. And now suppose here we want to define x by z. For example, x by z. So if we run this entire operation here, again, we are going to see the same result. Why? Because we have explicitly defined that z value should be equals to y, and y has been 7. So now if we change the value here, for example, let's say if we make this 35, and if we change the value as 5. So again, we are going to see the same result that we should expect. So here we have 7.0. Why? Because z is equal to y, so any change in value in y is going to also impact z, and that is what has been defined here as a part of assignment operators. If we define this as suppose plus, then what will happen now? Here basically here we are simply assigning the operator here, but again here we have add and assign. So add and assign simply means, now if we run this directly, then we are going to see an error being thrown to us. So basically here z hasn't been defined here, and z has to be defined here. For example, if we have already declared y, then we could have defined suppose y is equals to suppose y plus y. if we replace it, suppose here, as you can see here, this was bound to happen because z is something that has not been defined, correct? Now, but again, if we replace this with y plus equals to y, that means simply means this statement, what exactly it means? It simply means y here is equals to y plus y, y plus y. So that is what we have defined here as a simple statement here. So it simply means that when we are defining things here, it simply means that okay, y is equals to y plus y, a simple statement. And that is what we do by using assignment operators. So now if we go ahead and run this up, then we are going to see 3.5 because y plus equals to y becomes 5 plus 5 equals to 10, and 35 by 10 becomes 3.5 as a part of assignment operator. Same way we can go for minus equals to, for multiply equals to. For example, if we change this to suppose the asterisk symbol as it multiplies, so it is going to be 5 by 5, 25, and 35 by 25 is going to be 1.4 as a result of the assignment operator that we have, right? So here we have the comparison operators. So comparison operators is like comparison. If you want to compare the values with one another, like say, if you want to declare the values, for example, let's say here we had defined x is equal to suppose 3 and y is equal to 5. So now we want to compare the values. So here we can define if the value of x is equal to suppose value of y. So we can define that and then we can simply run this up. If it stands true, then we are going to see the value as true and false being returned. So as you can see here, x is not equals to y because 3 is not equals to 5, right? And same way here we can check, suppose if we want to check if x is greater than y, then it is going to be returned as a response as false. Okay, yes is less than y, and yes, true it is. And then we can same way define, suppose if we keep this as x, if x is greater than y, then it will return false because 3 is not more than 5. Same way here we can keep on checking on multiple values as a part of operators to check if the values are equals to, greater than, less than, or they are not equal to, then that is also going to be returned as a response. And then we have the logical operators to check if both the conditions are true or not. So we have and, or, and not operators. So for example, say here we can define two operators here. So here now basically here we have and, or, and not. So just like we add now in Java we add, suppose here in Java we add double n, right? Same way here we can add and suppose here we want to check if x is equals to y. So now we have defined two conditions. Here it is going to check if x is less than y, and if x is more than y, and if x value is equals to y, then only it is going to return it as true. If even one of the conditions fails, then it is going to return as false. All right. So now let's say here we define if x value is suppose less than y. Now this stands true, correct? This statement here stands true, but again, this statement is not true, correct? And that's why even though one statement is true, if the other one is false, then the return value will be a false only, right? But suppose here if we define, okay, if x value is equal to suppose 3. Now both the statements are true, correct? X is less than y and x value is equal to 3, and that's why the statement has been returned as true, right? And same way we have or. So if any single value is true, so or is going to simply return the condition as if any one of the value is true, then it is going to return it as a true response. It doesn't matter if the other condition is false or not. It is going to return true even if just one condition is returned as a true statement as a part of conditional operators. Next, we have bitwise operators. So they are used to manipulate the bits of the value directly, where we have AND, bitwise OR, bitwise XOR, and then we have perform left shift, then we have perform right shift. So for example, now here they are basically used for checking the bitwise values. So again, in terms of the bit values, then they are the ones that we make use of, especially in the calculations program here. Apart from that, we also have the identity operators. So basically, if it simply checks if they are identical or not, if it is or it is not. Suppose here we can check, suppose here we can define x is y. So we can simply define if x is y as in if the value of x is equal to y, then it is going to simply check for the response here. Suppose here we define this as 5 here. So again, it is going to check for the type of data as well. Again, as you can see, now it has been returned as true. So here we can choose is or is not, just like we have the other conditions defined here. Suppose if we define as if x is not y. Now this can be different values as well. For example, y can be suppose a simple string value here, right? So as you can see here, they both the values are not true at all, correct? So although we can see here, if we are making this statement here, now here we are checked for is not, then definitely x is not y, correct? Because they're not just the values don't match, because again their entire data type is completely different, correct? And if you run the statement here, then we are going to see false as a part of is and is not. All right. And then we have the membership operators. So basically, membership operators are mostly used when to check if a value exists or not in a given element or not. For example, here we want to check for a given element in a given array or array list, then we can, or even tuples, then we can check if the element is there, then we can simply go ahead and get the results here. For example, let's suppose if we define an array and now we want to check if an element is available in a given we can say is in a given element, then only one is going, or the true is going to be defined here. So for example, here we may define y as an array, and now we're going to check if one is in y or not. If it is, then again it is going to be done as a true response. As you can see here, one exists in this y array, right? Suppose if there was no one, then this would have been returned as a false. That means one is not an element available in the given array. And that is what we do by using membership operators. And as a continuation, let's also discuss on the concept of if-else statements as well. So for example, suppose here we want to check a simple condition. Then we can make use of if-else statement. So if-else is simply going to check if one condition is true, then it is going to return it, then it is going to execute those statements. And if one condition is not true, then the other type of statements, they are going to be returned as a response. So for example, let's say here we can go back. Here we have two different values. X, suppose, is equals to, let's suppose 30, and y is equals to suppose 20. And now we want to check if, now here we can define condition, if x value is equals to suppose y, then we can define what kind of statement to execute. So here we can define a colon, and then we can define, we want to print what? We want to print x is suppose the value of x and y are equal. Now, if we don't want to avoid any kind of statements here, so what we can do here, we can simply put the statement under double quotes here. All right. So here we have x and y they are equal. And then if you want to add more conditions, suppose else if, suppose if this condition is not true, then we can define else if as elif. And suppose here we can check if x suppose is greater than y. If this statement is true, then we can define print what? Print x is greater than y. And then we can define, again, if you want to check for more condition, we can define else if x is less than y, then we can again define a condition. Then if this condition is true, then we can define x is less than y. So here we are simply defining the condition-based statements here. So again, if we run this, as soon as if x is, as you can see, x value is not equal to y. So that's why the first statement has not been printed. Then it is going to check if x is more than y, then yes, this condition was true, and that's why this statement has been printed as x is greater than y. Suppose if we inverse this, if we keep this as 20 and 30, and again we run this up. So as you can see here, the first statement has not been executed because they are not equal. The second statement is also not false, and that's why it came down to the third statement. If x is greater than y, then again, that's why this response has been given. All right. So that is what we can find as a part of if and else statements. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.